Hi, so today we're going to be looking at the third project for fluid flow in Fluent, and we're going to start off by doing Inviscid. Going to go new design modeler geometry. Perfect, so we're going to go right into sketch, make sure we're on the z-axis here, and start by creating an sorry, I had to sneeze. Start by creating a circle here at the center point, and then we're also going to create some lines going out from the circle, of course at the center point. And some lines going up and down. Okay, perfect. And from there, we're going to go into dimensions. Click general. Just make sure these are 25. And lastly, this one's 25. Then for the diameter, we're going to put a diameter of 1 meter. And then we're actually going to go through and create a We're going to go through and create a rectangle here. That is going to be from this endpoint to this endpoint. And we're just going to go through and delete what we don't need. So, just going to go right into here and just select, delete. Perfect. Now we have our square as well as this. And we're going to go through and click box select. And we're first going to have to go through to a new sketch. Oh wait, no, sorry, concept, lines from sketch, surfaces from sketches. Click here and apply. And we're going to generate that surface. As you can see, the center is still open, which is exactly what we want to see. Then moving on from here, this is now done. We can double check ourselves by just going back into sketching, dimensions, general, making sure that this is 50 meters and this is 50 meters. Perfect. And it's centered around that point. So we're good to go. We can exit out of here. Next, we're going to go into meshing. Wait for this to load. And we're going to go right down into mesh. Well, first what I'd like to do is create my layer. So I'm going to go here. This is going to be our symmetry. This is going to be our velocity inlet. This is going to be our pressure outlet. And this is going to be our wall. Now we can go into mesh, insert method. This is going to be our geometry. Make sure we have triangles. And we can generate a mesh from here. And we can just see that from here, but what we want is to be way more coarse in the center right here. So we're actually going to go into mesh, insert sizing. We're going to do that for the edge right here, apply. This one's going to be number of divisions. Divisions are going to be 500. Capture curvature, no, and set this to hard. Perfect, now we can generate. Perfect. Then we're going to mesh, insert, and inflation. Apply. It's going to be our geometry. Our boundary is going to be this. It's going to be a smooth transition. Maximum layers of 200. 1.2 is okay for that. Now we can check our mesh. See, it's really, really, really small. All the way up to that boundary layer, which is perfect. And now we need to change just our element size here on the outside to make sure that we get a full analysis. This is going to be in mesh. Sizing. And we're just going to go to element size and drop this down to 1. See how that looks. We're going to want it a little bit more coarse than that, so we're going to go down to 0.1. Because we want the nodes down here to be approximately 500,000. Perfect. Now that our mesh is nice and tight like this, we can go ahead and exit out and update our mesh. Perfect. Then go into setup. Position a core start. Once this is done setting up, so we're going to actually be going into here and changing this to Inviscid. Okay. Materials are going to be our air, which is going to have a density of 1. Then our cell zone boundaries, let's just double check our inlet's going to be 5 meters per second. Our outlet's okay. Well, I'll just check that it's really perfect. Yeah, okay. Reference values are going to be from the velocity inlet method. So we're going to start off, or end off, by just going into our methods. Simple. This is actually going to be presto. Then let's just initialize this. Perfect. Just for the sake of time, we're only going to be doing 300 iterations, and then we can click calculate. And now that we have these values, we're going to be able to go down into this XY plot, plot the pressure coefficient. Then we can also go and plot our contours. So this is going to be our static pressure contour, as well as we're going to plot another contour. That's going to be our velocity contour. And then after this, we also have our drag coefficient. So that's going to be all for the oh, actually then we're going to go back into the workbench, go down into results. This is just so that we can make the streamlines around the cylinder. So once this is loaded, Z. Now we're going to streamline, start from the velocity inlet, down, all domains, apply. We're actually going to up this to about 500. And we could see here just how the flow lines just go right over and come right back down. There's no separation. And that's it for the Inviscid of Project 3.